All right. Good morning, afternoon, or evening, whenever and wherever you are, whether you're here in the room with us today or whether you're watching this recording an hour from now while you're hacking or 3 months from now or a year from now. My name is Luc.eth. I'm developer relations at the Ethereum Name Service. And today I have a bit of a cold, but I'll be running you through how to set up identity in your apps and all of the other cool stuff you can do with ENS, or some of the cool stuff. There is much more. And if you're interested, docs.ens.domains will have everything you need. So, quick agenda for today. We'll be talking about what ENS, why ENS, subnames, and all of the other cool stuff, how, and stuff you can build. Cool. So, for starters, what is ENS? ENS is super simple. ENS is a decentralized, permissionless naming protocol that lives on Ethereum and that scales to the entire internet. And so what that means is that ENS allows us to turn hex addresses like 0x225, F13714, yada 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 yada, C3b5 into human readable names like Luc.eth. In the same way that DNS allows us to turn IP addresses into usernames, or into domain names in this case, and ENS allows us to take hexadecimal addresses and Bitcoin addresses and any form of formatable address into a regular name. So anywhere you can put an IP address, like in a browser or an address or anything of the sorts, you can put a DNS domain name, and for the same right, anywhere you can read or write an address, you should be able to put an ENS name. Now, what that looks like is around about here on the left. You can see transactions. Normally, this would be a bunch of addresses, money coming in from here, going to there, left and right, into a contract and back and forth. But instead, you can just see that they're names because it's easier for people to do. And on the right, where you can enter an address instead of making a crucial typo and screwing up a major transaction to your friend or copying something wrong or having selected too few or too many, you just have a name and a profile picture and some other information to double check and give you that peace of mind when your users are going through certain flows. So ENS is a two-step process. There's forwards resolution, which is from name to address, for whichever coin type that is. And there's reverse resolution, which is from an address to a name. And so this allows us to let people sign into applications and then immediately show their username and their profile picture and their Twitter in the top right, or whatever information you want to show. My mouse is in the way. So ENS is not just a username, it's a whole set profile. We aim to extend DNS and add additional functionality. And so we can store all sorts of cool stuff inside of a profile. An avatar, a banner, a Twitter record, like I mentioned before, an X record. Bitcoin addresses, Litecoin addresses, Ethereum addresses, you name it. Down here, you'll see an array of sites that are all with Greg in it, of different websites that are gateways, if you will, where you can view profiles and anything of the sorts. So here's a really cool one, my absolute favorite, except for the other ones I made myself. The ENS Manager app, which allows you to view information about a profile. You can find it at ens.app/ whatever name you're looking for. And so in this case, this is my profile. I have some Solana records set. I have a bunch of social records set. I've got a description. I've got a location. I've got a website, luc.computer, which is also an ENS name. And I've got a whole bunch of other records that the Manager app might not support, but other apps can. And so you can leverage records if you wanted to in user profiles to do dark mode preferencing or anything of the sorts, whatever. Here's some more examples of that top right experience on every website you can imagine. With one line of code, it's built into WalkMe, no additional dependencies, or just one RPC call, you can showcase somebody's username. It's that easy. So, why? Users of crypto-powered experiences should never, in my opinion at least, have to interact with a hex address. Actually, users of any application should never have to interact with a hex address. Yes, it's cool to interact with hex addresses and to move them around from A to B and to be able to actually view what's happening under the hood. But my mom doesn't want to look through her transaction history and see a million transactions to all of these weird random places that are completely unknown, if she can also just see that it's an invoice from Coinbase and it was this and this and this, and that it was money sent to Luke and it was this and this and this, et cetera, et cetera. So it's about improving the user experience. To that extent, our logo is wrapping the Ethereum logo to improve the user experience. We are padding the Ethereum user experience, making it a bit more soft around the edges. So There's different types of ENS names you might want to know about. There's the native ENS TLD, which we created ourselves, is maintained on Ethereum mainnet, and it's the .eth TLD. And there's every other DNS TLD in existence, .com, .xyz, .io, .org, .computer, which I have one of, Luc.computer, .cash, .finance, and you name it. These are all usable within ENS because they're just regular domain names, and we're just a protocol that allows for a bit fancier resolution than regular DNS. We're just extending how it works. So to that extent, .eth names live on mainnet. They are fully decentralized. Once you own a name, you have the NFT. There is not a chance that anyone can do anything about it. And it is controlled by the DAO. So we have a decentralized autonomous organization. There's a whole spiel behind it. I encourage you to look into it. It's super interesting, but long story short, once you have your name, you're safe. And you pay an annual protocol fee to prevent squatting. So for a regular 5-letter name or above, that's $5 a year. We're not going to talk about 3-letter names. With regards to DNS, they're free. Well, I mean, you're already paying for a DNS name. There should be no reason you should be paying us. We're just a protocol. And so as long as you have a DNS name, you set a text record, and then your name will now magically work. Anytime someone does a lookup to the smart contracts will do an off-chain call, it'll read from your name, it'll verify all the information in there, do a signature check, and then be like, awesome, this is valid information. It leverages DNSSEC, it's cool, it's complicated, there's docs about it, not enough time in this talk. But the ownership is controlled by the registrar, which means that if you're getting a .com, VeriSign still owns your .com, you just lease it from VeriSign. If you have a .org, same story. And so you're still with the regular DNS ownership rules, whereas with ETH, once you have a name, it's a fight between you and the smart contract, and I rest assured the smart contract's winning. So there's also off-chain names and L2 subnames. Those don't have a protocol fee at all, and they give developers more flexibility. So the way that works is once you own a name, you can deploy a contract, a resolver, and you can basically tell that resolver to load information from another location, whether that's a contract on an L2 that does state root verification on the way back, or whether that's from an API off-chain. This is EIP 3668. There's docs pages about this. Don't worry about it. I've spent way too much time on it. You'll find out all about it. These are used by Coinbase, Linea, Uniswap, and many more in production. Got to make sure I don't accidentally do more name drops. And we've got some crazy, astonishing numbers as of recently. So more about how those work. How does ENS work as a whole? Super simple. We have a contract on mainnet. I will be oversimplifying a little bit. But essentially, we keep track of the name and the resolver and the owner. For Luc.eth, my resolver is 0x49 yada yada yada. This one will be familiar because a lot of us have this one. I'll get back to it in a minute. CBID has its own resolver. It's just a contract they wrote that then says, please load from this off-chain location. And Linea has their own same thing. Both of these contracts are 30 lines max, so I encourage you to have a look at them. You'll be able to look these up as well. Awesome. So the one I'm using, 0x49, is the public resolver. The public resolver is a contract we at ENS Labs have written, and it's the default for all of you who register a name through the ENS Manager app. The public resolver is just key value storage in a smart contract. And so I've uploaded my address, my text records, and my content hash, and anytime someone does a lookup for my name, it'll go to the resolver, it'll query the information, and it will just depot its, dump its storage slots. And so the public resolver has basic authentication built in, and the owner of a name has the ability to update its own text records. Pretty self-explanatory. It's a sensible default for most people. But if you wanted to build your own stuff, you can build your own stuff. And so in Coinbase's case, with cb.id, there's the off-chain resolver. So anytime somebody does a lookup to the contract, it'll revert with off-chain lookup. Again, 30 lines or less contract. And then it will hit some sort of API or some sort of gateway that then queries information from an L2 or that queries information from a database and then resubmit it to the contract on the way back to do a verification. This can be any arbitrary verification logic. You get to implement this in your contract, in your resolver. And so this could be a state root verification, this could be a signature check, it could be anything of the sorts. So those are CCIP read, again, EIP 3668. There's a whole docs page about this, docs.ens.domain/web/subdomains, everything you need to know. I'll link to it at the end of the slides. So This leverages wildcard resolution, the idea that you can do a lookup for a name and that it exists somewhere in the space. And so it will do name lookup from back to the front, from ETH to Luc to hello. So hello.luc.eth, all of that fun stuff. So super simple, look for the resolver in the registry. If it's not set, look for its parent, and then continue until a resolver is found. Basically, it's just how we do name resolution under the hood. And then we resolve the original name via the closest we can find. And so if my subdomain.hello.luc.eth exists, then it'll use that directly. But if it doesn't, it'll use .eth or it'll use .eth.luc or whatever the hell, depending on the order. Cool, so all of this cool stuff, EIP 3668, you'll find on the docs as well, and this is kind of what that flow looks like. And so you revert with off-chain lookup, it hits some sort of, like the client re-hits some sort of gateway, the gateway fetches the information, and then there's a callback function that does verification. Sweet, so Linea does this similarly. It uses the EVM gateway resolver, which is a template contract we've written that leverages 3668, so it's to make it easier, but it is also another name on the list of things you need to remember. Don't worry about this, it's in the docs. If you're interested, you'll find it. The EVM gateway resolver is basically just a contract that lets you verify storage slots on an L2. So if you wanted to issue subnames on an L2, you could just drop this in, and it will magically load the storage slots from your template contract. Cool, so there's the off-chain resolver and the EVM gateway resolver. They both use CCIP read, and they both read off-chain data, but one of them reads arbitrary off-chain data, and the other one reads from any L2. And so it's kind of a subset of off-chain resolvers as a whole. And same story, arbitrary verification and L2 state root verification. Awesome. So, take a breath. That is the deepest we'll go, okay? It's not that crazy. There's many different ways you can implement ENS. You can press buttons in the manager app and have a super user-friendly experience, leveraging the name wrapper, a pre-deployed smart contract that allows you to issue subnames on L1. Or you can take it all the way crazy and write a contract from scratch. And so there's a bunch of options in between. I encourage you to check out the docs.ensdomain/web/subdomains, and it'll have everything for you. So if you're issuing subdomains, this is where you've got to be. I'll keep it on the screen for a few seconds if you want to scan a QR code. This might be a Rickroll, so be careful. But it might also go to the right docs page. It depends. You never know with my slides. So if you're issuing subdomains and you're building something really cool, and during this hackathon you're like, yay, I want to give out free usernames to all of my users, this is where to be, and it will explain to you all the different fun options. So, building on ENS. We've got a couple of hackathon resources as well, another QR code or a Rickroll, you'll never know unless you scan it, so please scan it. And it contains the key concepts, some code snippets, random cool one-liners you can copy paste and do cool stuff with, as well as contact info. So should I not be hacking at the ENS booth or like harassing people for the next 72 hours, you can call me while I'm asleep in my hotel room because our contact info is on there as well as we have a ton of other wonderful ENS members around that you can harass to with all of your technical or non-technical questions. Cool. If you want any more project ideas, honestly, integrating ENS is one line. I wish I could give a bounty to all of you, but we cannot because they won't let us. And so we're giving out prizes to anybody who builds anything cool with ENS. And so I encourage you to build whatever your dreams desire and just give out subnames, and we'll be happy to help you out along the way. Cool, so we've got 2.5K for the most creative use case. We've got 2.5K for the best L2 experience. So if you're issuing subnames on Base or you're issuing subnames on Arbitrum or wherever your mind or heart's desires are, you can do so. And then we've also got 3 follow-up prizes, 2.5, 1.5, and 1K for honorable mentions. And so if you build anything cool in the ecosystem or like name renewal tooling or a registration site, then be my guest. Thank you. There's another QR code. I don't know what this one does, but that's fine. I hope you all have a wonderful day. Thank you for attending this talk. And if you're hacking, happy hacking. And I look forward to seeing what you guys build. Awesome. Cool. Am I still being recorded? Yeah. Awesome. If there's any more questions, I'll happily take them. We have a microphone over there, but you can also just yell them at me and I'll repeat them back for the room. Go for it. I I'm not sure, but I can look into that for you.
And you don't guess that, right? Like, can I...
So doc.dns domain/deployments, you'll find it, don't worry about it. We've got a deployment on mainnet, a deployment on Sepolia, and a deployment on Haleski. Those three are all linked to the deployments that they equate to. So mainnet is linked to base, but Sepolia is linked to base Sepolia, and then et cetera, et cetera. And so if you're using a Sepolia somewhere, I recommend staying in the Sepolia line of things and keeping all of the chain IDs correct. But resolution always starts at either mainnet, Sepolia, or Haleski, or whichever testnets come in the future, and then trickle down to whatever chains correspond. And so if you're working on a testnet, make sure all of them are testnet chain IDs. Cool. Go for it.
If you want to give us subname, subdomain for L2 name that is already existing,
Yeah.
can I just use EVM data resolver or is there something else you have?
Yeah. So the question was if you want to issue names on an L2, whether you could.
There is already a name on L2. I just want to provide one more subdomain for that.
Sure. Yeah. So the name will. Is this a second layer name we're talking about?
So I'll give you an example. The name on L2 is my name, like my name dot base dot e, and then if I want to give like blogs dot my name dot base dot e, so can I just use the EVM data?
So in this example, you have your name.base.eth. I'll take myself for the example, loosmans.base.eth. And then you want to issue subnames for that. So the difficult part here is that you're under the jurisdiction of base.eth. And that is under the jurisdiction of .eth. Now, .eth is a very free jurisdiction, and everyone can set their own subdomain. With base.eth, everything is controlled by a contract on Base itself. And so I would recommend looking into the particulars and whether they let you set a custom resolver, because they might not. They might only let you set records, and then the rest of the logic is just in the contract. But if you have a regular .eth, or if you have a DNS name, a second level name, so a luke.eth or a loosmans.eth or a luke.cache or luke.computer.com or whatever, those have full permission and freedom for you to issue as many subnames as you'd like. However, if you are on a subname basis, you're obviously dependent on the one layer above implementer, right? And so if I was issuing subnames under luke.eth, then somebody would only be able to do their own subnames if my contract let them do such a thing.